So far we've spent a lot of time talking about sine and cosine, but it turns out there are actually six trigonometric functions which relate to each other. The first we've talked about are sine and cosine. We abbreviate them with three letters, sin and cos, but you wouldn't pronounce this sin, you wouldn't pronounce this cos. When you say them verbally, you always say sine and cosine. Same when you put them in writing. You wouldn't write a sentence and say sin, you would say sine with the e on the end, the same with cosine. So we have a picture that we put up that usually looks like this, where we have some angle theta, we have an x, an r, and a y, but we don't always have to draw it in quadrant 1. It works just fine if we're in quadrant 3, where theta is still this counterclockwise rotation here. At least we want theta to be positive, it's counterclockwise. If theta is clockwise rotation, then it's just a negative angle. But the great thing is these formulas we're about to put up work no matter what. So we said that sine of theta is equal to y over r, and we said cosine theta equals x over y. Nope, x over r. So then we can go ahead and define tangent using the same picture. If sine is y over r and cosine is x over r, tangent we're going to define as y over x. So whatever the y coordinate is, divide that by the x coordinate. Again, we're always thinking that there's some point P here, even if we don't really label it or it doesn't figure into the problem. We kind of imagine it's there. So then we have what we call the reciprocal identities. CSC is cosecant, SEC is secant, and COT is cotangent. So CSC of theta is defined as r over y. So you notice we call it the reciprocal identity, or reciprocal trig functions, because this is the reciprocal of this. So since cosecant is r over y, sine is y over r, they're reciprocals of each other, so we can also write, so if you're ever in a situation where you have sine but you need cosecant, or you need sine but you have cosecant, is that what I just said? Doesn't matter. You have one, you need the other one. You can just use the value of 1 and do 1 over that to find the other. For example, if you want to find the cosecant of pi over 4, that's 45 degrees, well, you just know that's 1 over the sine of pi over 4. And the sine of pi over 4 is root 2 over 2. So flip this thing over, you end up getting root 2 when you do the algebra here. Cosine and secant are also reciprocals of each other. So cosine of theta is x over r, secant of theta is r over x, which means secant of theta is 1 over cosine theta, and cosine theta is 1 over the secant of theta. Same thing with tangent and cotangent. If tangent of theta is y over x, cotangent of theta is x over y. And they're reciprocals of each other, so tangent of theta is 1 over the cotangent of theta, and the cotangent of theta is 1 over the tangent of theta. There's another great fact here, because you might notice that y over r, x over r, y over x, you really only need these two, because if you divide these two, if you did y over r divided by x over r and you did the algebra on that, you would find out that tangent of theta equals, and we may as well just write this out, but if we take y over r and divide that by x over r, then we do the math you might have learned in some other class, is multiply on the top and bottom by r over x times r over x. Cancel, 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 cancel. The tangent of theta ends up being y over x, just like we said. But we started off with it equaling sine over cosine, so we know that tangent of theta equals the sine of theta over the cosine of theta. That's a fact you're going to get a lot of use out of in this class. Similarly, since these are reciprocals of each other, the cotangent of theta, just do the reciprocal of this, is cosine of theta over sine of theta. So then if someone asks you what is the cotangent of pi over 6, you say, okay, that's the cosine of pi over 6 divided by the sine of pi over 6. So then find these from your unit circle. You know the sine of pi over 6 is 1/2. The cosine of pi over 6 is root 3 over 2. And then do the math on that. Multiply on top and bottom by 2 over 1 times 2 over 1. cancel, 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 cancel. You end up getting the cotangent of pi over 6 is the square root of 3. And similarly, if you know cotangent of pi over 6 is the square root of 3, that means the tangent of pi over 6 is 1 over the square root of 3 because it's the reciprocal of the cotangent. So these are very useful formulations of all our trig functions. It can be difficult to remember which go together, so here's what I do. Cosine and secant both have 6 letters. It's not the most elegant mnemonic, but it certainly works for me. And then if you just remember that tangent and cotangent go together, that leaves these two left over, sine and cosecant, to go and be reciprocals of each other.